So, in our previous discussion, we have discussed how to draw, what is a Phasor diagram and how to draw it. We have got certain idea. Now, let me answer quickly that why to draw Phasor diagram? And obvious answer is that I may say that as many people used to draw Phasor diagram, it is available in the book. In your basic electrical engineering question, lot of people ask you, lot of teachers ask you to draw Phasor diagram. These are the reason. In a single word, it is like, the answer is like circumstantial pressure. But it is not the correct answer. The correct answer is that, before I discuss this, let me show you some illustration. Like, let us have A1 is equal to 100 sine omega t. A2 is equal to 80 sine omega t minus pi by 6. You can use radian or you can use degree, there is no harm. Okay, just a minute. A2 is equal to 80 sine omega t minus pi by 6. And another signal, A3 is equal to, say, 100 sine omega t minus, say it like minus 330 t. Now, for the first two you are quite confident that obviously the first A1 is leading A2 by an angle of 30 degree. But what about this A3? Whether A3 lags 330 degree or A3 lead, means A3 lags A1 or A3 lead A1. That is what we need to know. Now, the same thing, if we draw a Phasor diagram for the same, we can easily answer our question. So, how to draw that Phasor diagram? It's very simple. Suppose this is my A1, then here this is my A2. This angle may be somewhat greater than 30 degree, but you please try to understand that this is 80 sine omega t minus pi by 6, or rather this line is representative phasor for this signal 80 sine omega t minus pi by 6, and we have third phasor, that is yes. So this one is for 100 sine omega t. We can write it like plus pi by 6, or it is sine omega t minus 330. It's other way. So this image gives us very, means one thing that we can conclude from this image is that What is the essence of Phasor diagram, or what advantage the Phasor diagram offered to us is like it is easy to comprehend. Second one, this is first advantage. Second advantage is so let me write once again. Advantage number one is easy to comprehend. Now advantage number two, let me quickly rewrite the two equations once again. A1 100 sin omega t, A2 is equal to 80 sin omega t minus 5 by 6 or minus 30. Now I just draw a circuit like this. This is A1, this is A2. And I ask you to find out the resultant voltage. Clearly it is A1 plus A2. And how can you do it? Obviously you have to use your trigonometric means understanding you can apply here. Like you can divide both of them by those root under 100 square plus 80 square. That you all know, and even if you forget, you can easily rush to your trigonometry book and can brush up all these basic concepts to how to perform this and get some compact shape like something in magnitude, and then magnitude, or better to say not magnitude, rather you will have something bold A, this is for magnitude, and then here sin omega t minus theta. But for that you have to carefully apply all these trigonometric identity, right? Now, instead of doing all these, let us do one thing. Let us do a very simple thing. This is my Phasor for A1. Let me make A1 some small. Actually, I am also not habituated with this art of using this white board. Here it is no 30 degree, but you can understand this is a representation for it. Now, yes, this is our A2. Now what you can do here, this angle is obviously it is greater than 30 degree, but let us assume it is 30 degree. So what we can do here is that as it is right now they are just like a vector, we can draw a line that is from the tip of this A2 so again I have written this way. Okay. Now this is our A2. So then what you can do with the tip of this and this, you can join to find their resultant. This graphical representation, now this gives you this whatever theta you are looking for, this one, this entire length. Let me draw with a different color. So here this is our resultant and this angle is our theta. So if this one will give us this A sine omega t minus theta. Very simple. No need to do much calculation. Just if you draw the whole diagram in scale and don't draw a 40-degree angle or an actual 30-degree. That is what actually I have done here. You are bound to get a correct result without memorizing all these trigonometrics manipulation techniques. So that is another advantage, that here with this Phasor diagram you can exploit the rules of vector algebra. So these are the 2 points. One is easy to comprehend and will not get confused. It is a bit difficult for normal people to comprehend the position of the 2 waveform if only mathematical expression is given. Rather, a Phasor diagram gives us a very clear understanding, and that too without any means. You can have a hassle-free image of the 2 waveform when they are either leading, one is leading the other, another one is lagging the other. We can easily figure it out. And the second problem, the issue is here is that exploit the rules of vector algebra. And third point, that is more important, is that resultant is also in RMS. So why this is important? In RMS, why this is important? See, when we talk about our household supply, we say 230 volt, 50 Hz. This 230 volt is the RMS value of the supply. We never say it is 230√2 or the peak amplitude of our waveform. Why this 230 volt is significant? Because if you go for the physical interpretation of RMS, that I will discuss in some other day. This RMS has got a direct connection with the energy that can be extracted from a given input signal. It is directly related to our RMS. RMS carries that information. It doesn't matter what is the peak value of the voltage. So if you have difficulty in understanding, let me just give you one small example. Let us have wave like this, and then after this line the value of the wave is 0, and for certain time you will get some value of RMS for this signal. Or if you have problem in visualizing this, let me do one simple example. Suppose we have a periodic signal. So it is like this. You can calculate its RMS value. You will find some value. And suppose this value is M. And here you will take another sine wave. I am just drawing a free hand scale, it's not good looking. It is having magnitude 0.98. You calculate their RMS value. RMS value of signal 1. This triangular waveform is our signal 1. And this is our signal 2. You calculate and try to find out that which one is having more RMS value, and the signal that is having higher value of RMS is able to produce more, means if you feed both of them individually to identical identical load, then you will see that the load is able to draw more amount of energy, or rather all the loads, if you consider what are they are actually an energy conversion device, like an electric motor. An electric motor is an energy conversion device that converts electrical energy to mechanical energy. Now if you connect two identical motor with signal 1, you feed one motor with signal 1, and you feed another motor with signal 2, you will see the amount of mechanical energy produced by motor that is getting its supply from signal 2, it's quite, energy content is much more higher than that of the machine that is being fed by signal 1, right? So RMS is very important. Even if you are not getting RMS information, I can discuss RMS value later also if required. Okay. So the third point is that, so first one is easy to understand or easy to comprehend. Easy for calculation. And third one is that RMS value we can find out RMS value without doing any extra calculation. So these three are advantages of drawing a Phasor diagram. Now let us proceed to a section that a few important points to remember. Amplitude of the signal under observation must be constant. You can write sinusoidal signal under observation must be constant. And the second point is that the frequency of the sinusoidal signal must be constant. And if we want to plot multiple signals, all the signals must have constant amplitude. This amplitude, here I would like to elaborate. If we are done with the first 2 points, then I would like to highlight this third point. There is a space constraint. So third point, what I was trying to say, that if we want to draw multiple sinusoid on a single Phasor diagram, then the signals follow the below mentioned constraints. What are the constraints? All the signals must be of constant amplitude. Like the signals may have amplitude of the signals, it is not required. Like we can plot 100 sin omega t with 80 sin omega t. That is fine. We don't have any objection. But it is not allowed that we want to plot a signal like whose expression is like 100 t sin omega t. Then it gives an example of means a sine wave that is growing in nature. Now what is the problem? Like you have two signal 100t sin omega t and another one is like 80 t square sin omega t minus pi by 6. You said that the frequency are equal, so we can plot them, no issue. Go and plot them. But the problem that we will face, let me just clear the board here, actually it is space constant. During normal class I used to utilize all the board space. Here it is space constant. So here this 100t sin omega t, we plot it somewhere here, and also you have 80. You have a problem with 30 degree or rather 30 degree is angry with me. I cannot draw 30 degree perfectly. So at certain instant, say t is equal to 1 second, you got this one for 100, or more precisely the magnitude of this phasor is 100 by root 2. In another, and at the same instant it is 80 by root 2. But what will happen at t is equal to 2 second? At t is equal to 2 second, you will have this one magnitude will become how much? 100 into 2 by root 2, that is 100 root 2, and this one will become 80 into 2 square, that is 4, 80 into 4 by root 2. Like you will have 160 root 2. So can you imagine that earlier you represented them, one phasor was bigger in length and another one was shorter, and now what you are doing, you are at every instance you have to vary the length of the phasor, because they are continuously varying in nature. So how to, this is not possible. So in short, this is not possible to represent them in phasor diagram. Now the second part of this understanding is that not only constant amplitude, but they must have constant frequency, and moreover they must have, means all of them must oscillate with same frequency. All of them have to oscillate at a constant frequency. Right. Now all these, probably whatever I have discussed as of now, are all these known to you, and you are quite aware of all these things. As of now, I have not given you any cause to attend my class or anything to empower you. So here, let us move towards the special session, that is what extra you can get from my class. So the extra things. It sounds thrilling. Now this extra, first of all, think about it. Actually, as of now, we are discussing about signal or topic of discussion was signal. You have learned that a signal must satisfy these conditions, these prerequisites. So we can draw or we can plot them in a phasor diagram. But let us ask ourselves another question, that who produces or generates signal, right? Who produces or who generates a signal? See, here the obvious answer is, suppose you consider one simple alternator. Single phase alternator. You give mechanical energy here, you get electrical voltage across slip ring. If you assume that this alternator is ideal, then you should get a perfect sine wave voltage here. So, in a nutshell, what I am trying to say, that signal doesn't appear from heaven, doesn't come to us from heaven or by means of certain lightning. Obviously, lightning is also a type of signal, but in our daily life, every time it is not lightning. Every time whenever we are talking about signal, it is generated or it is produced by means of some system. So, what is a system? Now, the next question is that what is a system? In short, a system is a very abstract concept. You can describe system, can be anything like any physical system you can have. You can have like electrical system, mechanical system. Your bicycle is an example of mechanical system. And also you can have electromechanical system. Everything that you encounter in your daily life, whether it is physical or abstract, like you can also have abstract system, like our pedagogical process. Means this teaching learning process. This is also a system. Your banking is a system. Your nation runs on a system. Everything is a system. Now, what we can conclude that two things, that Or let me write the first thing, that is a system is responsible for production of a signal. Now it becomes more interesting. Why it becomes more interesting? Because consider a case. What type of case? Like, first of all, you answer me that do you think whether a transformer is a system or not? Obviously, it is a system. A transformer is a system. Now, given the reality, if we accept this, that transformer is a system, it takes certain input from your surroundings, it produces certain input to the surroundings. So, your transformer, I am not going to the literal description of system, but you can apply your common sense, you can intuitively understand that undoubtedly transformer is a system. Now, if transformer is a system, then what it takes? If transformer is a system, let me draw the transformer first. Just give me a minute to draw somewhat this is a transformer, although no, it looks like a transformer, but still it is a transformer. Here, this side you are giving input signal. You are getting output signal, right? Now, suppose it is like 1:2 transform, a step up transform. Fine. So, if your input is then your output should be let us also consider that this transformer, as it possesses some inductive circuit and we cannot avoid leakage inductance. I will describe leakage inductance later, but from your whatever you have learned in your basic electrical engineering. From that understanding, you just assume that there are certain inductor that is responsible for a phase lag of pi by 6 at output terminal. Now the question is that both these, as we know, transformer operates with constant frequency. It is a constant frequency, constant flux device. Constant frequency and constant flux, provided you keep the input signal unaltered. Transformer is a constant frequency and constant flux. We will come to that later. But think about this, you have 220 sin omega t and 440 sin omega t minus pi by 6. Now both the signals are of same magnitude, sorry, not same magnitude, both the signals are of constant magnitude and also they are having same frequency. So they satisfy all the prerequisites of our Phasor diagram. They are means at a glance it gives us an impression that they are means complying with all the requirements of drawing Phasor diagram. But in reality, what we can say that is more important question to be asked here, that how can you provide this input signal? You can't tell a transformer, now this is your input, you can utilize it. What do you need? Suppose you have a source over here. Say this source is this one. Now this source is 220 sin omega t, and obviously you can't connect a transformer permanently with source. You need some switch over here, and at t is equal to 0, say the switch comes to contact at t is equal to 0. The moment switch alters its position from open to close, we denote that moment as t is equal to 0. Now the question is that just after this switching takes place, can we draw the Phasor diagram? If you already if you get this picture, let me summarize that we are having one source that is 220 volt sin omega t. It is connected to a transformer through a switch. The switch alters its position from open to close at t is equal to 0 second, and after closing of that switch, some current will flow through the primary coil, some voltage will appear across the primary coil, and accordingly, by virtue of induction, we are bound to get some output signal. Now, whatever model we have studied, that we can see that output is 440 sin omega t minus pi by 6. Because transformer is a 1:2 step up transformer. Now here the biggest question is that, do you think at the very beginning of that switching we will get this 440 sin omega t minus pi by 6, or we have to wait for some time after which we will get this signal? So my question is that when this switching will take place, can we draw Phasor diagram immediately after switching? Like just after switching, can we draw the phasor diagram? That is question number 1. The second question is that when we are talking about system, in your basic electrical engineering, you must have at least heard of network theorems. And in those network theorems, you had superposition, Thevenin, Norton, and some max power, blah blah blah. So, for all these, this superposition, Thevenin, Norton, if you remember, you used to you had to memorize a lot of objectives. What are those objectives like linear, bilateral, time invariant? Lot of objectives you need to remember. Now, the question is that here, while we are talking about our phasor diagram, we have one system and we are giving it some input, we are getting some output. For that given system, let me write very clearly. For a given system, what are the prerequisites or prerequisite a system should fulfill so that we can draw phasor diagram for that system. And if means stated otherwise, it is very simple question. Let me use different color. Can we draw phasor diagram for any system or a system has to satisfy certain prerequisite condition. This is our question. And if we find out or if we understand a few constraints that a system should comply with so that we can draw a phasor diagram for that given system, the next obvious question is that what I asked you earlier during just a few minutes back, I was talking about at what time, like for time. So the constants are system specification and the second one is that time, let us write time factor, that whether it is means shall we have to wait for some time or it is means we can draw Phasor diagram for any system. We have to find out answer for these questions, and at the same time, before I give you the answer of these questions, another thing you should ask yourself that how this semester you will have circuit theory, you will have electrical machine, how these two subjects they are correlated with each other. You should not learn circuit theory separately and electrical machine separately. There must be some common understanding that will help you to understand electrical machine as well as your circuit theory.